So this video will be kind of a two-parter. Basically, that just means that this is angles and triangles number 4, and number 5 will just continue on with the work we've already done here. So this video is trisecting a 90-degree angle. And trisection just means 3. So if we cut 90 degrees into 3 equal pieces, it's going to be 30, 60, and 90 degrees. And that's what we're going to find out here. So I'm going to start by drawing a 4-inch line. I'm going to work right near the bottom of my paper here, because all my angles are going to be expressed up here. So I want to give myself lots of room. So to do this, I'm going to draw a straight line right across the bottom of my page. I'm going to do a 4-inch line. So here I'm going 4 to 8. Okay, just because my ruler hits the table. So there is my 4-inch line. Now, I want to trisect a 90. And what that means is I first have to get a 90. So I'm just going to again label this AB. It's kind of our starting mark for all the work as we start with that initial line. And I'm going to set my compass up. I'm going to go to a relatively large, but not too large radius off of this. Okay? It doesn't have to be anything exact. It's just something that we can work with. Okay? So I'm going to say somewhere there. So it looks like a little bit less than half, which is fine. I can go anywhere there. So now I'm going to scribe my arc. And this here is just putting up a perpendicular from A. If you look back to video number 2 last week for lines, we put up a perpendicular from B. This is just the same thing, but kind of from the other side. So now that I have this set, I want to set the compass on this point here. Let's call this point C. So then from C, I want to use the same radius and step off to create this point, which I can call D. And then again with the same radius, I'm going to step off and create point E. Now that I have a line, ED, that I'm going to bisect and put a perpendicular up from A. So you don't need to change the radius here, but you can if you want at this point. And I'm just going to draw an arc up here, and then I move over to E and draw another arc up here. So now I can take my straight edge, and then from A, I connect a line up, going through that point, which creates me a perfect right angle, and this is now 90 degrees, with this point here being 0 degrees. So from 0 degrees up to 90 degrees. Now, there's an interesting thing here that happens. This right here, this converging point at D, is actually already 60 degrees. So I'm going to step aside from this just for a second, and I'm going to explain this. I've already kind of done this in class with you guys, but let's just try it again here. So I'm going to set up a radius on my compass here. And I'm just going to pick a point here. And I'm just going to draw a circle. Right? Now, if I just pick a point to start, I'm just going to drop my point right here. And I'm not going to change my radius. I'm going to draw an arc. I'm going to draw another arc. I'm going to draw another arc. And I'm just stepping off the same radius as I did with the circle. Same radius I drew the circle with. I'm just stepping off the same radius. Okay. So again, I'm on the last one here. Step off there. And if I go here and use that point, you notice I'm hitting this exact point again. Right? So this is an exact step off of a circle using the same radius. It steps off the exact same amount of times. So now I'm just going to use blue here. And let's say I connect right through the center of my circle. Connect these points. I connect these points. these points. Then, to go a little bit farther here, I'm going to also connect these outside points. So I connect that one, that one, that one, I connect that one, that one, and of course, the last one. Now, what's neat about this is I have 6 perfect triangles. Now, remember, we created this circle with a specific radius, a radius of x, right? Which means all of these have a length of x, right? And then we stepped off the circle with the same radius, which means this is also x, which means all of these outside lines are also x. So what kind of triangle is this? What kind of triangle are all these? There's 6 of them. They are equilateral triangles, every single one of them. So what that means is each of these angles is 60 degrees inside this triangle. Each one of those is 60 degrees. So what that means is if I use the same radius to draw a circle and then I step off that circle, I'm stepping off 60 degrees. As long as you don't change the radius between drawing the circle and then stepping off of that circle, you will draw an exact 60-degree angle. Okay? And that's why when we're on this problem, right? I'm going to move the one from the bottom because it's showing through. But that's why when I have this problem here, I already have my 60-degree drawn when I throw off that perpendicular there. Because remember, I had my radius set from here to C, right? Which means when I step up here and draw this arc, and I step over here and do this arc, basically I'm drawing an equilateral triangle, right? Go back to equilateral triangles. I think that was number 2 from this week, right? And it's the same way we drew an equilateral triangle, which means that this first line here, right up from D, or from A, sorry, going through D, that is automatically already a 60-degree angle from 0. So from 0 to D is 60 degrees. Now, because of this theory, I want to trisect this. There's 2 things I could do. I could bisect between C and D, which would be bisecting 0 and 60, right? Which would give me 30. It would work, but there's an even faster way. Because, remember, if I use the same radius I used to draw the circle and step off of that circle from any point, I'm stepping off 60 degrees. Which means if I want to draw 30, I can just step off from 90 and scribe an arc down here, which means I'm stepping off 60, which leaves me with 30 remaining. So now I can take my straight edge and connect from A and go right through that point, which automatically draws me a 30-degree angle.